Like I'm going to get to certain points. I'm going to start like getting to the flow state. I'm going to know something. It's really no, it is nice. It's so much.
Okay, you read on absolute value graphs. Okay. You remember this was the general form of your absolute value graph. Okay. What does that A do?
Like which way it goes?
So it either made it be wider or narrower, so the gradients were either steeper.
So it's positive.
Or whether it's positive or negative, right? If it was negative, it was a valley. If it was positive, it was a hill. Yeah, with me?
Yeah.
Okay. And then we have got P and Q. What were they?
P and Q. The turning point.
Your salient point. Okay. So your P was your horizontal shift. Okay. If your normal graph starts on the origin, do you agree for this graph that has shifted 3 units to the right?
Yes.
And your Q was your vertical shift. So if your normal graph starts on the origin, do you agree this has been shifted 1 unit up? Okay. So in order to find our equation for this absolute value graph, we are going to start by first finding our P's and Q's. Okay. So do you agree? I'm going to write my equation like this, and then I'm going to solve for P and Q. Well, even if you can solve it, you can see it on the equation, right? Your salient point is 3 units to the right of the origin. If you are shifting a graph to the right, what sign do you use? Minus. So you've got -3 as your P. Then it says you have to add your Q. So if you're shifting it up, are you adding or subtracting? Adding. And then it's 1 from your salient. Right? Okay. Now, in order to find A, we need to substitute in another point that lies in this graph. Do you agree we've been given our y-intercept? Our y-intercept then has the coordinates of 0, 7. So we can go and substitute 7 in for y and 0 in for x. That's going to give you 7 is equal to A, absolute value of -3 plus 1. I take the 1 over, do you agree? I get 6 is equal to, what's the absolute value of 3? 3. 3. Okay. When you divide both sides by 3, you get that A is 2. So the final equation of your absolute value graph is y is equal to 2, x minus 3. Is everyone happy with this graph? Yeah? Should we try something slightly more difficult? It's a good thing you don't have a choice. I don't know how to get to the next page of this. Yeah. Okay.
So wait, do you want to put down the domains and ranges?
That doesn't ask for the domain and range. Okay. If the question asks for the domain and range, you can put that down. Okay. So we are going to look for the equation of this absolute value curve. So I'm going to start by just writing out the general equation of the absolute value curve because it gives me a nice starting point. Do you agree? So I've got y is equal to A, absolute value, x minus P plus Q. That is my general equation. Now we know we can find P and Q off the bat using our salient. Do you agree? Has your graph been shifted horizontally left or right?
Right.
Right. So what is your sign going to be inside that absolute value? A minus. And your P is in 3. And has your graph been shifted up or down? Up, so it's going to be a plus, and that Q is going to be 4. Okay, now to find A, we need to sub in another point that we have on the graph. Do you agree we've been given this point -3, -2?
Yes.
Okay, so I'm going to replace y with -2 and x with -3. Okay. And when you solve this, when I take the +4 over, do you agree I get -6? A absolute value of -6. Okay, what is the absolute value of -6? 6. So 6a. Divide both sides by 6, so what is a? -1. So do you agree now we have everything we need to write our equation out in full? So y is equal to negative. You don't have to put the 1, because it's like an invisible coefficient, right? With algebra, we don't put our 1 coefficients. So negative x minus 3 plus 4. Does it make sense that we would have a negative? Yes, because we have got a mountain shape, right? Okay. Can we move on? Is everyone happy with this so far? Nothing too challenging. Exciting. Okay. This one.
Oh, yeah.
Have you been given your salient point?
Nope, we're gonna find it, guys. That's fun. That's a fun part.
How are you going to find your salient point? Shannon?
Easy. I have a question.
Yeah.
That y equals x, to x plus 8. What does that mean?
So that is this line.
Oh, so these are like just two separate lines alone.
They're giving you, remember when we did the definition of the absolute value? We split it into two functions. And it was basically two straight lines that they meet to make an absolute value graph. So they're giving you the two straight lines that make this absolute value graph. Okay. So how are you going to get your salient point? Equate the two, because do you agree your salient point is at this point of intersection?
Yes.
Okay. So when you put these graphs equal to each other, do you agree you can say 2x plus 8 is equal to minus 2x?
Yes.
Great. So taking this over, you get 4x is equal to minus 8. So x is going to be equal to minus 2. Does it make sense for x to be minus 2 based on the picture?
Yes.
Yes, it's in line with the negative side of the x-axis. Do you agree? So far, my salient point is at a minus 2, and we want the y-coordinate of that salient point. I can then substitute x into any one of the straight line graphs to find that y-coordinate, because that point lies on both the green graph and the blue graph. Okay, I'm going to substitute it into the blue graph just because it's a bit faster. So y is equal to negative 2 times minus 2, which gives you 4. So that y-coordinate is going to be 4. Does it make sense for that to be positive 4? Because it would be in line with the positive side of your y-axis. Okay. So now you've got your salient point, which means if I look at my absolute value graph, which has got a general form of this, immediately I can fill in my PNQ. Okay. Has your graph been shifted left or right? Left. So what's my sign? Okay, so it's going to be plus 2. And then has it been shifted up or down? Up. So you're going to take that plus 4. We now need to find A. So we need to find another point in the graph. Okay, let's see another point in the graph.
Yes.
What is it?
That's 0 and 0.
The origin, right? If it goes through the origin, those coordinates are 0, 0. So I'm going to go and substitute in 0, 0. And when I solve for A here, I'm going to get minus 4 is equal to A times 2. Actually, value of 2, which you agree is just 2A. So A is minus 2. So your equation of your absolute value graph is y is equal to minus 2, open bracket, x plus 2 plus 4. Yeah. Would you expect it to be a negative A? Yes. Okay. So we're happy. It's getting exciting now.
Oh, actually, so
Yeah, it's getting exciting, and I'm so excited for you to experience this with me. Okay. Yeah. He's gonna listen to this recording, Sunny. No.
He's the one. He's the one. He is the conversation center.
We talk about fair share as well, don't we? Okay. Sketching an absolute value graphs in the form of y is equal to plus or minus the absolute value of f of x. So now, when we spoke about the basic definition of an absolute value in the beginning, do you agree we spoke about that making negative numbers positive? It's like the distance away from 0, right? So if we are making the absolute value of a function, we are looking at having a whole function with y values. If we're looking at the negative absolute value of the function, we're looking at our whole function having negative y values. So we're just going to take your core graphs that you should all know how to draw now because you've all been studying really hard for the November exam, right? Okay, so we are going to look at our method first, and then we're going to use the method for the first graph and continue from there. Okay. You're going to start by sketching y is equal to f of x. But if I look at this first example here, That f of x they're talking about is the function inside the absolute value. Okay. Do you agree that is just a parabola in this case? You know how to sketch a parabola. Or you should know how to sketch a parabola, and you will know how to sketch a parabola come the 11th of November. Okay. So we are going to first sketch that in pencil. Then you're going to interpret what they ask for. So if they are asking you to sketch the positive absolute value of f of x, you are going to reflect everything up over the x-axis. So everything that's under the x-axis now comes above the x-axis. If they ask you to sketch the negative absolute value of x, you are going to reflect everything above the x-axis below the x. Yeah. So let's start with this example here. So you want to sketch f of x. F of x is a parabola. You already know what your y-intercept is. What is your y-intercept? It's -8. Okay. So this is what I'm sketching in pencil. I'm sketching my parabola in pencil. We also need then our x-intercepts. Do you agree we would have x-intercepts because there's a smiley face parabola that starts in the negative region of the y-axis, right? So to find my x-intercepts, I make y 0. So I'm looking at 0 is equal to 2x squared minus 8. So 8 is equal to 2x squared. So 4 is equal to x squared. So what is x? Plus or minus 2. Which makes sense if we know a parabola would cut our x-axis in 2 places. Okay? We also know at this stage it is symmetrical about the y-axis. So we are looking at -2 and 2 as being the points of the scribe's triangle. And in pencil, we are then going to go and draw our parabola. Okay. Are you happy with what I've drawn as this parabola? Now you are asked for the positive absolute value of the function, which means we want all our y values to be positive. So we're going to reflect everything below the x-axis up. Okay. So let's look at this point over here, which I know is my y-intercept. If I reflect that above my x-axis, do you agree it's going to go there at positive x? Yes. Yes. Okay. Then this curve is just all going to be reflected upwards at me. So now you can do it in pen. Your absolute value graph is going to look like this red curve. We do not push these two arms below the x-axis because we need all of our y values to be positive. So they are going to stay above. Okay. Are you happy with what I've drawn here? What this means is that regardless of what is in here, every output is going to be positive. This graph over here is every y value positive. My red graph. Where does it start becoming negative? Yeah, right? So it's positive all the way up. Yes.
So why are we only drawing it?
Why are you only?
Drawing the positive?
Because you've been asked to draw the absolute value of the graph. So drawing the graph, this black graph that I drew in pencil, okay, that is the graph of y is equal to 2x squared minus 8. But the red graph is the graph of y is equal to the absolute value of 2x squared minus 8.
Oh.
This one over here, you have to have positive y values.
So it can only become, so it's the two elements and then that part.
Yes. So it's every red part here. Maybe I can put it in highlighted just so it looks a bit more visible. It's this full function here. That is the absolute value. We don't reflect the arms downwards because then they become negative y values. Okay. Are you happy with what I've drawn? It's fun, yeah? It's a good thing you don't have call today as well. Yeah. Okay, let's move to the next page. Okay, let's try this one. So our first step was to draw the function inside the absolute value of the place. Okay, so Drawing the function inside this absolute value in pencil. Do you agree it's going to start at -9? That is my x-intercept. I mean, my y-intercept. Okay. To find my x-intercept of that function, we're going to make y 0. And that's going to be 0 is equal to x squared minus 9. So 9 is equal to x squared. So x is what?
That's -3.
Plus -3.
Sorry, it's tired.
I know, everyone's tired. We're going to try and get through this as effectively as possible. Okay. So, when we draw this parabola, you are looking at something that looks like this. That is in pencil. Okay. That is my sketch. Now, what I want is g of x is equal to the negative of the absolute value. So let's think about what this means. Anything that gets plugged out of this absolute value, you agree is positive. But there's now a negative in front of it. So do you agree everything is supposed to be negative? Every y value that is generated should be negative. So I'm going to take this function and reflect it downwards from this x-axis. It's still going to keep its same shape. Okay. So I know that this arm over here would curve something like this below the x-axis. And this arm over here would curve something like this below the x-axis. And then this curved part of my parabola stays below the x-axis because it already has negative y values. Are you happy with this?
My plans aren't going great. My school probably
It's okay. We don't give art prizes in maths because then you'd be hypocrites. Okay.
That's just an art.
Maths is an art. I'm just not the most creative being.
But if I bend it, you bend it down.
You bend it down because it has to be negative y values. Okay. So everything here is negative y value. Got it?
And then this one, will it also be like back up?
Okay. Which one is it?
Oh no, the first one.
The first one gets made up.
Yeah.
Yes, because there's no negative. The difference is that you have a negative here. So any positive value that's generated by the absolute value becomes negative. Okay. We have. We move on. Now we lied to you.
And that's all.
We lied to you in core about asymptotes. So you cannot cut an asymptote for the real values of x. But you're an AP and we work with complex numbers. So your graphs cannot cut your asymptotes. Okay. It's not as difficult as it sounds, okay?
No way.
So,
Because now we're gonna do this.
no, you're not going to do this in math school.
God, this time I'm sorry. Like,
Okay.
you don't need. I don't because like, what's the whole point of the rules if they don't work after like a certain point?
Two different
No, no. It's one rule. It's one rule.
You chose to be here.
Yeah.
Okay. So we are looking at first sketching the function inside the absolute value. Do you agree? We have asymptotes for hyperbolas. Do you agree this is a hyperbola function? My x is in my denominator.
Yeah.
So we have asymptotes, and in pencil, we are going to sketch what this graph would look like. My asymptote, my horizontal asymptote would be at -4. Okay? So that is a dotted line here at -4. Okay, in order to get a nice shape, I need to sub in 2 points in this quadrant and 2 points in this quadrant to get a nice shape. Do you agree? So let's go, and first, we know we're going to have some sort of x-intercept because the graph is up or down. Oh, are you okay? So we know there's going to be an x-intercept because the graph is shifted up or down. So let's first find that x-intercept of this graph. To find the x-intercept, I have to make y 0. So I've got 0 is equal to 2 over x minus 4. When I take the 4 over, it becomes a positive 4, and it's 2 over x. You either multiply both sides by x and then divide by 4, you can swap the fractions around. Okay, I'm going to do the multiply by x one. It's faster for me. Okay, when you divide 2 by 4, you get a half. Do you agree with how I worked out my x's? So I know this graph is going to cut my x-axis at a half, which is halfway between 0 and 1. Okay. Then I want to find another point somewhere here so I can get a nice curved shape. So should we just substitute in 1 and see what the y value is? Okay, so when I take 2 over 1 minus 4, I've got 2 minus 4, which gives me minus 2. So the point 1 minus 2 is a point on the slot. So that is going to be over there, where I made this cross. So I can already draw the shape of this quadrant, if you agree.
Yeah.
I know that my y-axis is an asymptote, so I'm not going to cross that. I'm going to tend towards it. Okay. Okay. That is the first side of the hyperbola, but we know that there's two sides of the hyperbola. So let's go and get 2 points for this side. Okay. So we are looking for, should we see what it is at minus 1? So 2 over minus 1 minus 4 gives you minus 2 minus 4, which is minus 6. So the point minus 1 minus 6 is on this graph. Minus 1 minus 6. Happy with my substitution? Okay, let's look at what minus 2 is. 2 over minus 2 minus 4 gives you minus 1 minus 4, which is minus 5. So that is this point over here. Okay, so drawing this shape then, we're tending towards our asymptotes. And it looks something like this. This is your pencil sketch, right? That's okay, just make it a different color. Make a note to yourself. Okay. So now we are going to go and look at this formula. Do we want the positive absolute value or the negative absolute value? Positive absolute value, which means we want all our y values to be positive. So we're going to reflect everything below the x-axis above, including your asymptote. Okay, so let's start with the asymptote. So I'm going to draw my absolute value graph in green. Okay, so when I shift my asymptote up, it comes to 4 instead of minus 4. Okay. And what's nice now is we have a bunch of points that we can then shift up as well. So the point 1 minus 2 stays in line with 1, but becomes the positive version of the negative, right? So it's 1 and 2, which is that point over there. Okay. The point negative 1 and minus 6 becomes negative 1 and 6. And the point minus 2 and minus 5 becomes minus 2 and 5. Okay. So let's draw what this thing looks like. This arm that's going to tend towards this asymptote over here has to look like this blue one below. So we're going to curve it up like that. Okay. This arm that was the blue arm, do you agree, already had positive y values? So it stays there and look, it cuts its asymptote. Okay.
Yeah.
Wait, what?
It cuts its asymptote. But don't panic, it's right. We're in AP here. Okay. And then we have to reflect the blue graph on this side so it looks something like what's underneath, and it should look something like this. So your absolute value curve of this hyperbola is that. Because all our y values are positive.
Can you have a big highlight?
Just underneath. I did.
Okay.
Just 1 second.
Are we happy with what this graph looks like?
Yes.
Yes? Are we getting the hang of this? No.
This is actually really, they look so pretty.
I know.
It's perfect that I don't get back with those man. Wow.
Well,
I didn't say great.
Yes, you did. You were like, great.
It was a sarcastic great. You're going to move on and do more. And by the end of the lesson, you're going to feel fabulous. Okay.
Fabulous.
You don't feel good.
do you or do you not feel really done?
Okay, let's move on to the next one. Now I don't know how to do this thing.
Not feel good. It's fine.
Okay.
I lost two papers. Imagine not coming to school. Oh, imagine not coming to school and you have to do this.
There's a recording.
Yeah, no, but now I was one lesson of what to get and what getting of cubic equations. Yeah, no, it's
Okay, let's start. We're drawing the function inside absolute value first. Where is your asymptote, your horizontal one? Positive 6, which is, yeah. Okay. This is the pencil function. Then we want to go, and because it's been shifted up or down, we know there's going to be an x-intercept. So we're going to work out what that x-intercept is. So to find our x-intercept, we make y equal to 0, right? So we've got 0 is equal to negative 3 over x plus 6. So minus 3 is equal to negative 3 over x. So minus 6x equals minus 3. So x equals a half. Okay, catch up. You can tell me if my equation's wrong. I've been doing math a lot longer.
Aren't you like 25, 23?
Every age but my age, I'm 24.
Really? You see, I was in the morning. If you made that an average, I would be technically the meaning of those two values is.
But I've still been doing maths longer.
Yeah, it's longer than us, of course.
Yeah.
But then
So you'll be able to do this if you keep with maths.
Yeah.
Like at that rate.
you know, sometimes it's a very difficult platform.
Okay.
Yes.
That one big out.
Is that the plan?
That is the backup of all backups.
Okay.
What's up now?
You must be working about time.
Okay. We need another point to get our shape. Can we substitute in x as 1?
Yes.
Okay. So I've got minus 3 over 1 plus 6, which is going to be minus 3 plus 6, which is 3. So at x is 1, we have got a y coordinate of 3. So it is going to be there. Already we can then give a shape for this curve. Do you agree? This side of the curve will look something like that. Okay. We still need this part of the curve, right? So we're going to go and substitute some two values there. So let's look at minus 1. So if I substitute in minus 1, I'm looking at 3 plus 6 equals 9. So minus 1.
But they won't intersect.
Yes, over there you should because it's not a line there. So that's a hard 0. Okay. If it goes through a direct line, it's basically labeled 4 there. Okay. So that's 9. And then we're going to substitute in. There's no real nice value. Let's substitute in minus 3. So if I substitute in minus 3, I've got 1 plus 6, which is 7. So minus 3 and 7. You can work with decimals if you want, but it's nicer to try to get a whole. Okay. So that is the point, minus 3, 7. Now we're going to go and join those points. Like so. That is my pencil sketch. Now we're going to go and look. Do we want the negative absolute value or the positive absolute value?
Negative.
So do we want positive or negative y values?
Negative.
So we're going to reflect it this way about our x-axis, right? We're reflecting it down. Everything reflects, including our asymptote. I'm going to do it in green. Okay, my asymptote was at positive 6. It now becomes negative 6. Okay. Then I'm going to reflect down some points. So this point over here was 1 and 3, so it's going to be 1 and minus 3. This point over here was minus 1 and 9, so it's going to be minus 1 and positive and negative 9. And this over here was minus 3 and positive 7, so it's going to be minus 3 and negative 7. Which is name. Now we got to find our shape. So above the x-axis, this curve was tending towards the asymptote like this. So below the x-axis, it's going to tend this way. You're imagining if this is like a really, like a wet paint and you're folding it over, will this look the same as this once you've unfolded it? Okay. This arm over here was already negative, so it stays, it cuts our asymptote because that's fun, and it goes down again. And then this curve over here, we have to look and mimic the same shape, tending towards the asymptotes, like so. So the graph of your absolute value graph is this. Okay. Technically, we should also label this asymptote as y is equal to minus 6. Okay, and we've labeled out x intercept. How do you feel about this? Now, a bit better? Let's do exponential functions.
Are you sure?
I'm
Yeah.
sure.
We got this, guys.
I'm sure we should do them. Why don't we start the fun now?
But like, I feel, how sure are you? I feel like,
I'm quite sure. Okay, let's scroll down. Okay, what's our first step? Exponential, okay. So this exponential graph, what can you tell me first about it? Horizontal asymptote is negative 2 over here. Then we have to go and find an x-intercept because we know it's going to exist because it's been shifted up or down. Well, because it's been shifted down. Okay, so we're going to go and find our x-intercept of this function by making y equal to 0. So 0 is equal to 2 to the power of x minus 2. And I take this 2 over, it becomes positive 2 is equal to 2x to the power of x. Exponential equations. We've got the same base, so we can drop the base and make our exponents equal. Okay. So our intercept is at x equals 1, which is there. Now we want to find another point so we get a nice shape. Should we just substitute in 2 and see what that is? Okay.
We could substitute it.
You can substitute in anything, but let's keep it as simple as possible. Okay, so it's 4 minus 2, which is going to give you 2. So at 2, we have a y value of 2, which is that point over there. An exponential function, so it's going to go like
Y-intercept.
or we can even find a y-intercept. Okay, your y-intercept is where x is 0, right? Well, it should just actually intercept at 1 above, but we can go and do it anyway. Your y-intercept is where x is equal to 0. So you're then looking at 2 to the power of x minus 2, which is 1 minus 2, which is minus 1. So it should somehow go through here. Pretend mine does. Okay. Should go through minus 1 on the x-axis, 1 on the minus 1 on the y-axis, 1 on the x-axis, and the 0.22. Are you happy with that? Yeah. Great, we've got our pencil sketch. Are you asked for the negative absolute value or the positive absolute value?
Negative.
So do you want positive or negative y values?
Negative.
So are we reflecting up or down?
Down.
Down.
Okay.
We're going from side down. Okay.
Yeah.
Yeah,
I thought you meant like that.
okay. So everything that is above the x-axis then gets translated down. So asymptote can stay where it is. Do you agree? It was already in the negative region.
Yes.
So now I'm going to take my 2, 2, and I'm going to reflect it to 2 minus 2, which is on the asymptote. Okay? And then I've still got this point, which is fine because it's on the x-axis, and I've still got my y intersected over there, which is fine because it's below the x-axis. So now I just have to mimic the shape. So it looks something like that.
Why did you reflect the asymptotes?
The asymptote was already in the negative region.
Oh,
If
Okay.
it wasn't in the negative,
You would reflect. So that is your negative absolute value of that exponential graph. Feeling confident? Fairly. Okay. And we should label this as y equals negative. Okay. Last one.
never read this service and kind of.
And I can't see that because of recording. Okay, let's see if it is free. I'm going to give you time to try and sketch this one yourself first.
That's what I was. This was the
You have a break in your future. 4 days coming up.
that's not a break, that's another math. That's not break, that's
Join the club. We don't have a break either.
Yes. So mine is zero to very exact. It has to start in. So it, let's say why. You need to say why. Why negative. It's negative to zero. Oh, please, such a why the negative. It makes sense.
Central camera to put the robots, but then now it's so technically.
Then, I'm just looking.
So that's fine. Just draw the absolute value on
See, the wine. Now, up the test, why is my. But.
I think it's, yeah, now, what should I do? So if I'm reflecting this,
But how is the wine? Like,
if I'm reflecting this, when it shines like this, oh yes.
Okay.
So take the one is connected and everything has to be positive, right? So take and everything that can cause that is.
Yeah. Oh, maybe I'm like showing some of that.
You have to say that. No, but you said that representations are not.
Yeah, but we gotta make it make sense.
Yes, so you, yeah.
Or was I?
Yes. There is a graph that I can show you that you are very
What line?
you are back is
Here we go.
This is still the white. That means green.
There we go.
It's something for your life.
And like this.
So then it's nice. Wait, you said white? That's something that system done. Then since I will be
Wait, but you need to go through it first.
yeah, this I go like this. I think this. That makes it. Because don't you have like so the other things that get up my fingers. Okay, it's gonna be three. Yes, that's why. Oh, like this, it looks like even this. Yes, because. Yes, right.
So your pencil sketch should look something like this. Cut the y-axis at -3, cut the x-axis at 2.
You want to help with Bonita?
Okay.
But we're not gonna.
Wonderful. Because you look bonita.
Say they're running back right now. Oh, that I didn't do.
Why must I do that?
Because you can do this whole time. No, I have to commend you for allowing us, or not allowing us, for getting us one type of skills in 1 hour.
Do you not work with staff fusion?
We do it with more chats. Maybe actually we have
So we work fast in my class and then practice. And we chat there.
Oh, that okay, that's a break. We have like a break. Yeah, we have a break. We have like 5-minute break because we need to have like a timer on the break. And then we have time in some
10 minutes.
for how long.
You can go and get your
I thought you need to start the line next to something.
Well, it's on the actual points though, Nina. See, it's on 3 and it's on 2 already. Okay.
Well, no, just put it to the box. So you actually can get the marks. Yeah, I can see it.
Bye. Are you happy?
No, I'm not gonna lie.
So what if I gave you a really weird function?
I think we're I wouldn't be happy. I think we're
But what if we tried one just together?
function you wanna give her. Ma'am, can we give you a function? And see what happens.
And you want to see if I can do it?
Okay, I'll see you can do it. And it's just, you know, see how you not even. No. Maybe, ma'am,
Okay, the function I'm giving you is this.
ma'am, that was the one. You wait.
And I'm calling that f of x. And I want the absolute value of f of x. And I'm going to call this, let's give you some y. Let's give you some points. Yeah, I'm giving you some coordinates. Wait. Let's make this 4, this is -4, this is 3. Yeah, you should be able to do it from here, just roughly.
I'm guessing the 2 points.
But it's just, remember, we're just looking at reflecting it above the x-axis, right?
Make a like triangle kind of one. No, they will. I'm so. Oh, it's just a triangle and then you connect it.
So can I just go +4 there
And then
and then just connect it here?
yes.
So do you agree this is my absolute value, girl?
Yeah. Okay. You got to. Hey, well, when did I answer? Since
It's quite cool, man.
I was fun.
I'm gonna do it because it's fun.
I love my.
You know why you're fun, son?
Because those are like alone and like, oh.
Okay. You can work on something for your exam.
I didn't even